Hello, welcome to 821, day 2. Today we're going to continue our discussion of complex numbers. We are going to more explore polynomials that have roots that are complex. As we saw in yesterday's lesson, we saw a polynomial that did not have any solutions in numbers that we knew about at that time. So now that we know about these complex numbers, we can actually start exploring polynomials that have roots, but are not numbers that we're normally used to, right? So they're complex roots rather than what we would call real roots, all right? We're also going to spend some time just practicing simplifying expressions with complex numbers in them, and we're also going to take a look at polynomials that have complex roots using the graph. So like, what does a graph look like when they have complex roots, all right? So let's get into it. So like I said, yesterday we looked at a polynomial that had complex roots. So we are going to take a look at a few more of those today. So this polynomial that we're starting off with here is going to have a couple of complex roots. So let's see where they pop up and see if we can find them. All right, so when we talk about roots, right, roots are the same things as zeros, and they also tell us where the x-intercepts would pop up. So one way that we would start to look for the roots is by taking this polynomial and setting it equal to 0. Right, so we get something like 0 equals x squared minus 4x plus 5. And we would want to solve this equation for x to find the roots. Okay, so the way we're going to do that is we are going to use the quadratic formula. You might remember this from in the beginning of the year, right? So the quadratic formula looks like this. It's negative b plus or minus square root of b squared minus 4ac all over 2a, okay? So we're going to use this to help us find those roots, okay? So we first have to identify what a, b, and c is. And if you recall, a is the number in front of x squared. So in this case, a is going to be 1. And b is the number in front of x. So that's going to be negative 4. And c is the constant on the end. So that's going to be a positive 5. So I'm going to take my a, b, and c. I'm going to plug it into the quadratic formula and see what we get. So we're going to start off with a negative 4, right? Because we have a negative with the b and a negative built into the quadratic formula. So that's where we get the two negatives from. And then we're going to have plus or minus the square root of b squared. So that's going to be negative 4 squared. Minus 4 times a, which is 1, times c, which is 5, all over 2a. Right, so 2 times 1. All right, and then we simplify this expression. We start to evaluate it, and that means we're going to go through just piece by piece looking for an easy thing to do. That's the way I always explain to students is when we're simplifying this type of an expression, just look for one easy thing to do. All right, so for instance here, negative 4 becomes positive 4 because two negatives, when you multiply them, become positive. Okay, and then I'm going to go in the square root. Negative 4 squared is a positive 16. And then we have 4 times 1 times 5, which is 20. So we have 16 minus 20 inside of the square root. And then in the bottom, 2 times 1 is just 2. All right, so we did a bunch of stuff there. Now we're going to keep looking for easy things to do. So another easy thing to do would be 16 minus 20. So that's going to be negative 4, right? So we've got 4 plus or minus the square root of negative 4 all over 2. All right, so it's starting to simplify a little bit here, and we're gonna work to the right. Okay, so notice here that we have a square root of negative 4. Now back in Algebra 1, when we ran into this situation, we'd simply say no solutions, right? Because we didn't know how to handle the square root of a negative number. But now that we know about complex numbers, we do. We know this is a number. Okay, so I'm going to take this square root of negative 4, and I'm going to rewrite it just like we did in yesterday's lesson. I'm going to say, well, this is negative 1 times 4. And we can split that up, so we can say the square root of negative 1 times the square root of 4. Well, we know the square root of negative 1 is I, and we know the square root of 4 is 2, and I times 2 is 2i, right? So we can say 4 plus or minus 2I over 2. Okay, so that's where those complex roots pop up, is when we run into this situation inside of the square root where we end up with a negative number inside. That's when those i's are going to pop up when we're trying to find roots of polynomials. Okay, so we're going to simplify this just a little bit more. So you'll notice that I have two numbers here. I have the 4 and the 2i. Both of them are being divided by 2. So I'm going to go ahead and do that, right? So 4 divided by 2 is 2. And then 2i divided by 2, right? It's like the 2's will cancel there. So we're just going to get 2 plus or minus I. So here's our two roots. Okay, so one of the roots is going to be 2 plus I, and the other one is going to be 2 minus I. There's my two roots. Okay, that's as simple as that is going to get. There's nothing left to simplify there. We cannot combine these. 2 plus I is not 2I. 2 minus I is not 1I. These are not like terms. This is a real number. This is an imaginary number. We can't combine those. So this is as simple as it gets, and these are the two roots of this polynomial. Okay, so that's where they come up, and we're gonna practice a few more of those later on in the lesson today. So we'll see another couple of examples, but I just wanted to make sure you guys saw, like, these roots do exist, these complex roots, and this is where they come from. All right, so let's go down here. What about the graph? What does a parabola look like when it has complex roots? All right, so we're going to take a look at these graphs here. So we've got some polynomials here. We've got 3 different polynomials. They're all second degree polynomials, so they should have 2 roots no matter what, right? And we kind of see in this first one, when we look at the graph, we can see the roots correspond to the x-intercepts, all right? And we have to remember this x-axis represents all real numbers, right? So all of the normal numbers that we usually find are located somewhere on this x-axis here, and we can see 2 roots at -5 and -1. Okay, and that's really easy to find because you see them right there as they cross the x-axis. This one is a little bit more tricky. It has to have 2 roots, but we only see one place where it crosses the x-axis. But notice that it comes down, it touches the x-axis, and then it bounces right back up. And if you remember from previous lessons, when we see a bounce, that means this is a double root. Okay, so that means that the root of -3 happens twice, right? So it's like -3 twice. There's 2 roots. It's just the same root 2 times when we see that bouncing behavior. Okay, now this one, you're probably looking at it and saying, well, I don't see any x-intercepts, and that's how you know when a parabola is going to have complex roots. So, or a second degree polynomial for that matter, right? So there's no x-intercepts, but it has to have 2 roots, okay? They're just not going to be on the x-axis because they're not real, right? They're not real roots. They're complex roots here, okay? So we're just going to say complex for now, okay? And if we were to take this equation and do what we did just up above here, if we were to solve it for 0, we would find a couple of roots with i's in them, all right? So sometimes if you're not sure, like if you're trying to find roots of a polynomial and you're like, okay, I'm having problems finding it, you might want to take a look at the graph and just see, well, if it doesn't cross the x-axis, that means we're going to have some complex roots that we need to find, okay? So that is the graphical connection to those complex roots. So let's take a look at a couple more here, right? So we're going to solve each of these, right? And see if we have real roots or complex roots, and we're going to apply that quadratic formula for each of these. These are all second degree polynomials, so this is a really good tool to use to find those algebraically. So we're going to use that same method, right? We're going to find A, B, and C by looking at the standard form of our polynomial here. So notice in front of the x squared we have a 1, so A is going to be 1. B, right, we have a -1 there, so we're going to say B is -1, and C is this constant on the end, so that's going to be a +1. And then I'm going to plug into my quadratic formula. So we have -b, so we'll have -1 plus or minus the square root, and then we have b squared, so we'll have -1 squared. Notice how I put that in parentheses. That's really important, especially if you're going to try and use the calculator to simplify this expression. You want to make sure you put that negative in the parentheses before you square it. Otherwise, the calculator will not give you the correct answer there. We're going to go minus 4 times a, which is 1, times c, which is also 1. This is all over 2a. Right, so 2 times a, 2 times 1. There we go. And then we just simplify piece by piece, right? So I always like to start out here out front. So we got the negative 1, that's a positive 1, plus or minus, and then I go into the square root. Well, negative 1 squared is positive 1. And then we have minus 4 times 1 times 1. Well, 4 times 1 times 1 is just 4. So 1 minus 4. All over, and then 2 times 1 is 2. So I take my time, I go piece by piece, making sure I don't make any mistakes along the way. The biggest downfall of the quadratic formula is that there's a lot of little pieces to watch out for, so there's a lot of room for mistakes, and you just got to take your time and do it piece by piece, otherwise you will make a mistake. All right, and a quadratic formula takes practice, right? The more you practice it, the less mistakes you'll make. All right, so we're going to keep going here. The next thing that we can do 1 minus 4, right? So we got 1 plus or minus, we have a square root. 1 minus 4 is just negative 3 over 2. And notice we end up with that situation again where we have the square root of a negative number. All right, so I'm going to take that over here and I'm going to turn it into its complex form. All right, so I'm going to separate that. I'm going to say negative 1 times 3. That's still inside of a square root. And then I'm going to split that square root up. Just like that. Okay, so remember the square root of negative 1 is I. And the square root of 3 is not a nice number, so we'll just leave it as the square root of 3. So we get I root 3. So we're going to say 1 plus or minus I root 3 all over 2, just like that. And then we need to split that up into 2 separate roots. Okay, so the first one's going to be 1 plus I root 3 over 2. And then the second one will be 1 minus I root 3 over 2. So it's like here it's just written as a combination of the two, right? Because they put plus minus in one expression. Here we just separated them into 2 separate answers. Okay. So those are our 2 roots. They're both complex, right? Because they have an I in them. If I were to look at the graph of this polynomial, we would not see any x-intercepts. Okay. So just a couple of connections to keep in mind as you go through these. All right, let's do another one here. Let's do part B. Okay, so we'll do the same thing. We're going to use the quadratic formula. So we've got A, we've got B, and we've got C. All right, A is the number in front of x squared, so that's going to be a 1. B is the number in front of x, so that's a 6. And C is the constant on the end, so that is 25. And I'm going to make sure we separate so we don't get confused here. So we've got negative B, so that's going to be negative 6 plus or minus square root of b squared, so we got 6 squared, minus 4 times 1 times 25. Okay. All over 2 times a, so that's going to be 2 times 1. And then I just go through and simplify piece by piece, right? So negative 6 is going to stay negative 6 this time. We don't have that double negative to worry about this time. And I'm going to go inside my square root. 6 squared is 36. Minus, and then 4 times 1 times 25 is 100. And then 2 times 1 is just 2. All right, and we keep going, right? So the next thing we're going to do is the 36 minus 100. So negative 6 plus or minus. 36 minus 100 is 60. It's going to be negative 64. Oops. And that's all over 2. So we're going to work to the right here. And we've got negative 6 plus or minus square roots. And then we've got negative 64 here. So the square root of negative 64, let's bring that over here real quick and see what we get. So we got the square root of negative 64. We'll separate the negative 1 from the 64. So we got negative 1 times 64. And then we can split up that square root, just like we did in yesterday's lesson. Right? We know this is I by definition, right? And the square root of 64 is just 8. So we're going to get an 8I. Okay, so we're going to say negative 6 plus or minus 8I all over 2. All right, and we need to make sure that we're looking for opportunities to reduce this fraction when possible. So when I look at the two numbers in the top, so like I have a 6 here and an 8I here, the 6 and the 8 are both divisible by this number in the bottom. If that's the case, go ahead and divide those two numbers by 2. Right, so negative 6 divided by 2 is simply negative 3. And I've got my plus or minus. And then 8 divided by 2 is 4, so we're going to say 4I. Okay, so there's my two roots. I just have to split them up, right? So we're going to have negative 3 plus 4I, and we're going to have negative 3 minus 4I. And those are my two roots. Right? So not too bad. It's not too hard to find those complex roots. It's just a matter of making sure that you recognize when you're going to have those complex roots, and that is going to happen whenever you get that negative inside of the square root. All right. So we're going to do it one more time. We've got a second degree polynomial here. It says 3x squared plus 48. Remember, another way to write this, right? So this one only has two parts instead of three, right? So it's got a 3x squared, it's got the constant, but it's missing that middle piece with just a regular old x. All right, and if that is ever the case, you can always rewrite it like this, where we take 3x squared plus 0x plus 48, right? So if it's missing that middle piece, it's a 0. All right, so you can just say 0x. And then we can find our A, our B, and our C values. All right, so that way we can use the quadratic formula. Section off some space here, right? So A is going to be 3, B is going to be 0, and C is going to be 48. All right, and then I'm going to plug that in, right? So we're going to have negative B, so it'll just be 0 plus or minus the square root. And then we're going to have negative b squared, or I'm sorry, just b squared, which is 0 squared minus 4 times 3 times 48, all over 2a. All right, so we got 2 times 3. And we're going to go through just, again, piece by piece, taking our time, making sure that we don't make any mistakes along the way. So we've got 0 plus or minus. 0 squared is just 0. Minus, and then 4 times 3 times 48. You need to whip out a calculator. Go ahead here. I do. All right, so 4 times 3 times 48. Let's see what we get. So 4 times 3 times 48. We get 576. No problem. There we go. All over, and then 2 times 3 is 6. Okay. So simplifying this a little bit more, you're going to get 0 plus or minus, and then you get the square root of negative 576, right? Because 0 minus 576 is negative 576 all over 6. Okay. And then I'm going to come over here. I notice we are going to have some complex numbers again, so I'm going to turn this negative 576 inside of the square root. I'm going to turn that into a complex number. So I'm going to say negative 1 times 576. And we get the square root of negative 1 times the square root of 576. That's going to be I times, I'm going to go to my calculator for this one. So I'm going to say second square root of 576 equals, and we get 24. And so we got 24I. Right. So we got 0 plus or minus 24I all over 6. Okay. Almost there, almost there. All right, so we're going to get 24I over 6, right? Because 0 plus 24I is just 24I. So we get 24I over 6 and then negative 24I over 6, right? And these are divisible. So if I do 24 divided by 6, I'm going to get 4I. And if I do negative 24i over 6, we get negative 4i. So there are my two roots. All right. Okay, let's go ahead and finish this off. We're just going to practice a little bit of the simplifying stuff again. We saw this in yesterday's lesson. I just want to make sure that we know how to deal with these. All right, so this is a complex number, just needs to be turned into its complex form. So we do that by separating that -1, right? So we're going to say -1 times 81, and then split the square root. So we got the square root of -1 times the square root of 81. So this is I times 9, which is 9i. Okay. And then let's simplify this one. This is very similar to what we've been seeing when we've been doing those quadratic formulas. So we've seen the square root of -25 before. We know the square root of -25 is 5i, and that's going to be over 2. And we can just leave our answer like that, right? Because if I'm looking at these two top numbers, the 3 and the 5, neither one of those are divisible by 2. So there's no need to take this any further. We can just leave it like this. Okay. So let's give this one a try. So this is 16 plus or minus the square root of -64. So we see that complex situation going on right here. And we actually did the square root of -64 in one of the previous problems. So we know that this is going to be 16 plus or minus 8i, right? That negative square root of 64, okay, is 8i over 2. 16 and 8 are both divisible by 2, so I'm going to go ahead and divide. Right? So 16 divided by 2 is 8, and 8 divided by 2 is 4. So we would just say 8 plus 4i, 8 minus 4i. And for this one, we don't have to separate them. We'll just keep it like this. We can say 8 plus 4i and 8 minus 4i. All right. All right, let's do one more. So I'm looking at this one. I see the square root of a negative number here, so this is one that I can turn into a complex number. So for now, I'm going to leave that first part alone. So I'm going to say -2i squared. I'm going to leave that alone for now. I'm going to turn this into its complex form. All right, the square root of -16 becomes 4i. And now I can carry out my multiplication here. But first, I'm going to do this exponent. So don't forget to square everything inside of the parentheses. Right, so -2 squared is a +4. And then we have I squared. So this will be 4i squared times 4i. Right? And then we can multiply the 4's, get a 16, and we can multiply the I. So I squared times I is I to the third. And if you recall from yesterday's lesson, I to the third is simply negative I. So this would be -16i. All right, guys, that's it for today's lesson. If you have any questions, make sure you let me know in the Zoom chat. Be happy to answer those for you. Otherwise, give the practice problems a try and see what you can do. Good luck.